You may say that, well, that's easy peasy. Well, okay. Now let's go to the second compartment technique. Independent sample t-test or unpaired samples. The independent sample t-test, also called the unpaired sample t-test, is the most common form of the t-test. It helps you to compare the means of two sets of data. For example, you could run a t-test to see if the average test scores of males and females are different. The test answers the question, could these differences have occurred by random change? The two other types of t-test are one sample t-test, used to compare a result to an expected value. For example, do males score higher than the average of 70 on a test if their exam time is switched to 8 a.m.? And the second one is paired t-test or dependent samples, used to compare related observations. For example, do t-test scores differ significantly if the test is taken at 8 a.m. or noon? You should use this test when you do not know the population mean or standard deviation. And the second one, you have two independent separate samples. And we also have the assumptions for the independent sample t-test. First, assumption of independence. You need two independent categorical groups that represent your independent variable. In the above example of this score, males or females would be your independent variable. The second one is assumption for normality or assumption of normality. The dependent variable should be approximately normally distributed. The dependent variable should also be measured on a continuous scale. In the before example, on average test score, the test score would be the dependent variable. Third, assumption of homogeneity or variance. The variances of the dependent variables should be equal. Now, how to run an independent sample t-test? I also will tell you the way to understand or to calculate or to run the independent sample t-test both manually and with SPSS. Check this out. Okay, now let's go to the independent samples t-test. I have one question for you. Calculate an independent sample t-test for the following dataset. Dataset A 1, 2, 2, 3, 3, 4, 4, 5, 5, 6 and dataset B 1, 2, 4, 5, 5, 5, 6, 6, 7 and 9. So, how to do this independent sample t-test? We have some steps to here. The step 1 is sum the two groups. We have to sum it all and we got 35. And also for this 1 plus 2 plus 4 plus 5 plus 5 plus 5 plus 6, 6, 7 and 9, it is 50. Step 2. Square the sums from step 1. I will just write it down for you. This is the step 1. Oh, sorry for my bad writing. And this is for the step 2. Square the sum. Means for A is 1225 and for B 50 square is 2500. Set this number aside for a moment and let's go to the step 3. Step 3. Calculate the mean. So how to calculate the mean? It is very simple. You just need to divide this sum with the amount of the data set, which is 10, and also this divided by 10. So you got for data A 35 divided by 10 is 3.5, and for the data B 50 divided by 10 is 5. This is the mean. Then step 4. Square the individual scores and then add them up. Square the individual score and add them up. So what does it mean? So this is like this one. 1 square plus 2 square plus 2 square plus 3 square plus 3 square plus 4 plus 4 plus 5 square plus 5 square plus 6 square. Just use your calculator or your Excel. It will be more easier, I promise. And you will get 145. And for the data B, you have 1 square plus 2 square plus 4 square plus 5 square plus 5 square plus 5 square plus 6 square plus 6 square plus 7 square and 9 square, and you got 298. Set these numbers aside for a moment too, and then we go to the step 5. The step 5 is insert your numbers into the following formula and solve. This is the formula for defining the t-score in independent sample t-test. I know this is very complicated, but it is easy actually. You just need to put the numbers based on the formula here. Okay, let's do it together. So, what is mu A? Mu A is mean of data set A in the step 3. How much is it? So you can see the mu A is 3.5. This is the mu A. Okay, I will write it down for you. So this is the mu A, this is the mu B, and we have this one, the sum of A square. The sum of the square of data set A, we can find it in step 4. This one, step 4. This is the sum of A square, and this is the sum of B square. And next is sum of the data set A squared. Sum of data set A and then squared. So we squared it in the last time. So it is this one. We have it in step 2. So this is sum A squared and sum B squared. So don't be confused, don't get confused with the bracket and without the bracket. If without the bracket, so we score it one by one, and at the last time we add them all. But for the square, we bracket it first and then we just square it. It means we sum them all first and then just get squared the sum. Okay, so you know this. And what is the NA and B? This is the number of item in dataset A, the number of item in dataset B, which is both of them are 10. So, well, we have got all the numbers and then we just put the numbers into the formula. Mu A means 3.5 minus mu B means 5 divided by, make it big because it is so long, formula. This one, sum A squared. Sum A squared means 145 minus this one, 1225 divided by 10, and then plus 298 minus 2500 divided by 10, because this is NB. Sorry, it has to be small n, not a big N. Okay, take this one and then divided by 10 plus 10 minus 2 times 1 divided by 10 plus 1 divided by 10. Okay, then you got T equals minus 1.5 divided by 145 minus 122.5 plus 298 minus 250 divided by 18. Wait. Times 2 divided by 10. T, you still with me? Minus 1.5 divided by 3, 9, 17. Like this, and become like this, and you got, finally we got minus 1.69. This is your T-score. Okay, now step 2, find the degrees of freedom. Sorry, step 6, find the degrees of freedom. How to calculate the degrees of freedom? The degree of freedoms is NA minus 1 plus NB minus 1. So 10 minus 1 plus 10 minus 1 equals 18. And then look up your degrees of freedom in the T table. If you don't know what your alpha level is, use 5%. So let's check our book. So guys, you have got the T-score of minus 1.69. So we have to find the T table. The T table here. So how many of your N? Your N is this one. The degree of freedom is NA minus 1 plus NB minus 1. So 10 minus 1 plus 10 minus 1, it means 18.
So you can see here, because this is two tails, guys, two tails, you can see the hypothesis. There is no difference between means and there is difference between means. It means two tails, because if one tails, the hypothesis will say there is less or there is more, because it is only different, not less or more. So this is two tails. For the two tails, the alpha has to be divided into two, so it's not 5% anymore but 2.5%. Let me see you here. 0.025 and the degree of freedom is 18, so you got the t table is 2.101. The t table is 2.101. So based on this hypothesis, we can draw the graph here. The cutoff is minus, because two tails, so you have the left side and the right side. The minus 2.101 and 2.101. So whenever your score is here, your t-score is here, is in this range, so your hypothesis null is accepted. But if your t-table is more than 2.101 or less than minus 2.101, so it means your hypothesis null is rejected. Now you can see that your t-score is 1.69 and it is in the range of this one. It is something here, somewhere here. It means that your hypothesis null is accepted, that there is no difference between means. Now let's use the SPSS to solve the question for independent sample t-test with the same question. So first you have to click the variable view and type the name, the data. It contains of the data A and B, so just type the data and then the type. The type here for categorized whether it is the data for A or for B. Then after that, make sure the measure is scale. After that, you click the data view. I'm so sorry, I'm cheat here to make it fast, so I just copy it. So this is the data from dataset A, so I give the code 1 for dataset A. This is the dataset A, 1 up to 10 and 11 up to 12. 11 up to 20 is the data set B. So we make data A and data B into one column, which name is the data, but we categorize it into the type column, one for data A and 2 for data B. So let's click the analyze and then compare means. And let's click the independent sample t-test. Okay, we start again from the first. Click the data and enter it into test variables, and then click the type and enter it to grouping variable. Now define the group that we have. Basically it is still empty before, so group 1 is for the data A. The data A is categorized by 1 here, so just put 1. And for the data B is the group 2, and we categorize the type into 2 here, so we click 2. After that, continue and OK. Well, here you got the group statistics, and you can see here that the mean of the data A and B are quite different. For the data A, the mean is 3.5 and the data B mean is 5. But whether it is can be justified as difference statistically or not, let's see the second table. The second table here, you can see here, this is Levin's test. Levin's test is used for testing the homogeneity of two data sets. If the significance here is more than 0.05, it means your data sets are homogeneous. I repeat it. If your Levin's test or your homogeneity test here show that the significant column is more than 0.05, it means your data set is homogeneous, or the equal variance is assumed. And the homogeneity test is the test that we have to take before we test the equality of means using t-test. Because if we want to compare means, we have to compare the apple to apple. So they have to be homogeneous. If they are not homogeneous, it means the t-test will also say that they are different, because for the first time they are different, not homogeneous. But if they are homogeneous, we still need to do the t-test, because we need to know whether they are homogeneous too statistically or not. So they are homogeneous here. They are homogeneous. So let's take a look at the t-test here. Take a look at the significance here. If the hypothesis alternate is accepted, the significance has to be less than 0.05. If the significant column here less than 0.05, it means that the hypothesis alternate is accepted. But here, the significant column showed 0.107. It means this is more than 0.05. That's why it is concluded that the hypothesis null accepted, which is there is no difference between means. And hypothesis alternate is rejected. There is difference between means is rejected. Here we can see that the hypothesis null is accepted because there is no difference between means. It is same as the manual calculation we did before. So now we can conclude. Even though the mean here looks different, but statistically they do not different. So that's why we should test it using statistics, because something that looks different doesn't mean that they are really different in terms of the statistics.
Isn't that easy? Okay, next we go to the third compare means technique, which is parity t-test, or paired sample t-test, or dependent sample t-test. A parity test, also called a correlated pairs t-test, a pair sample t-test, or dependent sample t-test, is where you run a test on dependent samples. Dependent samples are essentially connected. They are tested on the same person or thing. For example, knee MRI costs at two different hospitals. Two tests on the same person before and after training. Two blood pressure measurements on the same person using different equipment? Well, choose the priority task if you have two measurements on the same item, person, or thing. You should also choose this task if you have two items that are being measured with a unique condition. For example, you might be measuring car safety performance in vehicle research and testing and subject the cars to a series of crash tests. Although the manufacturers are different, you might be subjecting them to the same condition. With a regular two-sample t-test, you are comparing the means for two different samples. For example, you might test two different groups of customer service associates on a business-related task, or testing students from two universities on their English skills. If you take a random sample each group separately and they have different conditions, your samples are independent, and you should run an independent sample t-test, also called between samples and unpaired samples. The null hypothesis for the independent sample t-test is mu1 equals mu2. In other words, it assumes that means are equal. With the parity test, the null hypothesis is that the pairwise difference between the two tests is equal, or hypothesis null, mu d equals 0. The difference between the two tests is very subtle. Which one you choose is based on your data collection method.
Well, let's say that some students given tests before and after the treatment for mathematics competition exercise. So, before the treatment, this is their score 1, and there are 11 students in this mathematics class. This is the score 1 before the treatment, and this is the score 2 after the treatment for just say 1 month intensive treatment for joining the mathematics competition. So we want to know whether there is difference or not before and after treatment. Of course, the hypothesis null said that there is no difference of mathematics score before and after treatment, and the hypothesis alternate said that there is difference between there is difference of mathematics score before and after treatment. So because this is manual, so first we have to make a additional column of x minus y here. X minus y means score 1 minus score 2. Okay, like this one, and just drag it and you simply got the number. And then this one, x1 minus score 1 minus score 2, and then we square it. So like this, 1 is squared. Okay, got it, and then we drag it. Okay, now we have got this one. Now just calculate the sum or the total of x minus y here. So like this. Okay, what is it? Oh, it's wrong. This is the total of x minus y, and we drag it here. Okay, and this is the total of x minus y, and then squared. And then we go to the manual calculation. Well, this is the calculation for the parrot sample t-test. After you calculate all of the components of this formula using your Excel, you need to compile it in this t-score formula of parrot sample t-test. Okay, let's do it together. So D equals the sum of D. The sum of D is minus 73 divided by N. N is 11. Divided by the root of 1131 minus 73 squared divided by 11. Divided by 11 minus 1 times 11. So we got minus 73 divided by 11, and the root of 1131 minus 5329 divided by 11 divided by 110. So if you calculate all of this, we will got that t-score is minus 2.74. This is your t-score. And in step 6, subtract 1 from the sample size to get the degrees of freedom. We have 11 items, so 11 minus 1 equals 10. Step 7, find the p-value in the t-table using the degrees of freedom of 10. If you don't have a specified alpha level, use 5%. From this sample problem, we can see so this is 10 and 5%. It means 1.812, but if you make it two tails, so you have to divide it the alpha. 5% divided by 2, it becomes 2.5% here because it is two tails, so you got 2.228. So your t-table is 2.228, and this is your t-score. And let's draw the graph here. This is your t-table, minus 2.228 and 2.228. Whenever you are here, it means your hypothesis null is accepted. If it is more or less than this range, it means your hypothesis null is rejected. Hypothesis null rejected. So where is minus 2.74? Minus 2.74 is out of here. So like this one, minus 2.74. What does it mean? It means the hypothesis null is rejected, or the conclusion is we can reject the null hypothesis that there is no difference between means. It means there is difference between means. You can ignore the minus sign when comparing the two t-values, as plus or minus indicates the direction. The p-values remains the same for both directions. Well, okay, now let's use the SPSS to calculate this data. First, open your SPSS in the variable view, and then for the name, just type before and after. Okay, and the measure here, you click the scale because we have the scale measurement. And after that, you go to the data view and you can copy it from the Excel. You also can give name of variable view here, like in the Excel, like score 1 and score 2, but I just prefer to use before and after because it is more makes sense for the case here, because the case here is before and after treatment for mathematics competition. Sorry, wait, we copy it from here to here. Well, okay, then we go to analyze, compare means, pair sample to task, and variable 1 is before and variable 2 is after. After that, just do let's look at the option here. Okay, the confidence is 95% like we did before. The alpha is 5% and then okay. Well, you can see here that this one, the mean before is 15.18 and after is 21.81. But does this difference of mean is justified statistically? Just go to the pair sample data. Here you can see that the significant column is less than 0.05. It means that the hypothesis null is rejected and hypothesis alternate is accepted, which is there is difference of mathematics score of students before and after treatment. So the conclusion is same as if you use the manual calculation.
Well, now you have known about 3 of compare means techniques, which are one sample t-test, independent t-test, and paired t-test. And we still have one other test, which is ANOVA test, but the ANOVA test will be explained in the next meeting. So just wait for the ANOVA test for the next meeting, and don't forget to do your assignments, and bye bye for now.